And I always need to mute this broadcast because I'll have a double audio. Okay. All right. So last class, I think we finished. I think we were looking at the different ways of manipulating walls, and we look at the constraints. So in our level 3, we created groups. And groups is an important concept, especially if you are using modular distribution of spaces on different areas of a floor plan, or if you're using a multi-floor arrangement of apartment or condo types, then you may want to take advantage of groups. When you create a group, you're going to see the different groups that are created in your project under the group tier of the project browser. And notice how the typical office row, it's there for you. And there's also an array group, which was the result of creating an array of different desks. And I think I said that I was going to review the process of doing arrays, and we're going to do that now. So under the Modify tab, I think we cover most of everything that is in this Modify panel. These are the modifiers, and these are ways to change and manipulate geometry in Revit. So just to review, the first one, it's align. This is align. This is copy, offset. This is move, sorry. This is copy, offset, rotate. These are two types of mirror. Mirror, you pick in a line. Mirror and drawing a line. Fillet, trim to a corner. Fillet, extend to one element, extend to multiple elements. Pin, unpin, delete, scale. We use scale when we were scaling the image, remember? And then the split. And the last one I need to show you is this one, which is the array. And I did that last time, but I did it very quick, so I'm not sure if a lot of you got it. So let's take some time to do this in a more slowly. And then this other one, which is right here, it's split with a gap. And what that does, it's not used very frequently, but let me show you what that is. If I have a wall or a floor and I want to divide it with a specific gap, then I can use that split with gap tool, which works exactly like the regular split, except that now you have the ability to create a join gap. And this is if you want to create like structural joints or separation joints between structures or assembles, then you can specify how big that joint is. And when you select a wall, it will create that element for you. That's. And if you notice, it creates a dimensional constraint. So what that means is the gap will be preserved in the event you shift the wall. Oh, I guess not. It's just start to break in. But if I select this wall and I try to move it, it's going to carry the wall with it. So it doesn't treat these two. I mean, these are still two segments of a wall, but they have a locked dimensional constraint that is preserved and carried along the project. But frankly, I don't use it that often, or I haven't seen this used very often, but it's there for you use. Yeah, so that's a split with a gap. Now let's check this array again, and I'm going to go back to my floor plan level 3 with the one that had my initials. It's a working view. And let's also bring some chairs and table. So I'm gonna load those families from the library because I don't have them in my project. So you go to the Insert tab. Go to the Insert tab and then go to Load Family. This is going to display the English Imperial folder, and scroll to the Furniture folder. And I'm going to bring a round table. So there is this round table here. There's also the dining round. Let's do the table round. And let's also load some chairs. So you can go back to load family. Revit, always remember the last folder you browsed. So I'm going to go back to the furniture folder and look for the seating. These are different type of chairs. Frankly, the ones that are not very pretty. But let's bring this chair brewer. And those two pieces of families that I just brought from the library are going to be available under the furniture category in the project browser. And when you load a component into the project, you can drag and drop directly from the project browser, or you can go to the architectural tab and hit place a component. And the difference between this is that Revit always remember the last component you loaded to the project. So if I hit place a component, it's going to place the chair brewer because that was the last one I brought in. So place a component and just place one here. And then if we want to do the table round, let's pick the 48 diameter. You can just drag it and drop it. Then escape. I have one family of each, the chair brewer and the table round 48-inch diameter. I'm going to move this table a little bit here on the right, and let's explore the process of creating rectangular arrays. So an array, it's a distribution of elements in a matrix display. So you have to define the number of elements, the number of rows, and it also, when you finalize creating an array, it creates a group, and that group is going to be listed under the group branch of the project browser. Notice how when we created that group of desks inside this conference room or this training room, the array group is listed inside the model. This is this in here. And in fact, if I drag and drop the array group, actually the first one is the very first one. This guy is the very first array. And then that is brought into the project as a group. But let's do it with just the chairs here. So the array tool, it's when you select the chair, the array tool is this icon with 4 little squares in the modify tab under the modify panel. And you have the ability of create a group based on the distance between the first element and the second element multiplied by a factor, or between the first element and the last element. And those two options are available here. So when you say move to second, you are graphically specifying the distance between the first element and the second element, and then is going to array the number of elements you indicate in this cell. And if you do the other one, which is the last one, you specify the distance between the first element and the last element, and then equally distribute the number of elements between those two extremes. Another thing you may want to consider is to constrain it. When you constrain it, you make sure that the array is always orthogonal. So I'm going to create a first row of elements in the horizontal. So this is going to be like, let's say, 6 chairs, total of 6 chairs. And the distance between the first element and the second, it's indicated here. And I'm going to constrain it, meaning that I want Revit to make this array orthogonal. And so if you zoom in, you're going to see 2 boundaries. That is a representation of what is a group. And then I'm going to indicate the distance between the first element and the second element. These lines that pre-highlight are reference planes embedded inside a family. So when you hover over on top of them, they highlight. And so I'm going to pick the first click is a point in that reference plane. And then I'm going to say that these chairs are going to be placed 2 feet apart. So the distance, center to center. Yeah. And this is center to center is 2 feet apart, and there's a total of 6 elements in the horizontal. And because it's constrained, it's going to make it orthogonal. And here's the thing, Revit gives you a chance to change the number of items. Because I put 6 here, I have a default of 6 elements. We change it to 8. And now you have a different array. Now, this is a group. When you select any of the instances, you are going to see that the total number of items is going to be displayed as a variable that you can change. So at any point during the design, you can always come back, pick any instance, and click on the number to change the new number of arrays. Or change this to 10. So that changed the number of elements. Now, if I select one of these elements and just move it, say I'm going to move this 4 inches, notice that the distance between the elements also changed. So I don't know the dimension of this chair, but I want them to be shoulder to shoulder. Tap. All you need to do is move this element from, let's say, this endpoint and make it snap perpendicular to the other one. Now all these chairs are like one next to each other. So different ways of modifying an array after it's created. You can change the number of items, or you can change the distance between them. Say if I want them now to be have a gap of 4 inches in between, and move that from here to here. Actually, I need to move the one of the intermediate elements. Yeah, if I move the first and the last one, it doesn't change the spacing. It needs to be one of the elements in between. All right, so I have a total of 12 items, maybe 4 inch in between them. And this is a rectangular array. Now I can use this whole array, and I can also array it. Like this, the name of this group, it's a model group array group 2. You see here. I can grab all these chairs or all these, I can grab the array group number 2 and I can array it. So I can make an array of an array. And I'm going to activate again the array command. And this time I'm going to do number 6 rows. And rather than using the method from the first to the second, I'm going to use the last method. And what that means is that graphically, I'm going to indicate the distance between the first element and the last element. And Revit is going to equally subdivide the location of the rows in that distance. I'm also doing the constraint so that it remains orthogonal. So again, the distance is the last. So I'm going to say I want these elements, the last element of this array, to be 16 feet away from the first one. So anything in between will be equally spaced. And so no need to do this one by one. Just do an array on the horizontal and then do another array in the vertical. And the beauty of this is that you can always go back and edit the original ones. So if I need now A rows, just change it here. And remember, the method is important because the method doesn't allow me, it's always going to redistribute the elements based on the first and the last one. If, say, the distance between the first one and the last one change, all I need to do is move the last row, and then everything's going to be readjust accordingly. And then I think you can even tab, hover over and hit the tab to access one of the nested group elements and redistribute the distance between them again. I want to say it's from here to here. It doesn't let me do that. If I could do that. Select this, then use the move command. Now, once a group is inside a group, it cannot be edited. So in that case, I will have to ungroup and do it again. But these are two groups. One is nested inside the other one, and once a group is inside another group, you cannot access the original properties. Is it clear? So I'm gonna, assuming that this is a open space training center, then you can move that from one place to another one. What's happening? It's my Revit froze. There you go. All right, any question about arrays? Pretty straightforward. The other type of array, it's the polar arrays. And this is when an item creates instances in a circular fashion. And for example, I'm going to again drag and drop a chair, a Bauer chair from the families. So just going to the families and look for the furniture chair brewer. And notice how Revit loves to align stuff. So internal reference planes of families snaps accordingly. I'm going to snap to this table at a quadrant. You almost feel it like snaps. And now rather than creating a rectangular array, I'm going to create a polar array. A polar array distribute a number of elements in 180 degrees. So pick the element, well, go to the modify tab and hit array. So the first, sorry, I'm gonna cancel it. I have to select the element first. Select the element you want to array, and then you hit the array command. Now, instead of using the rectangular array, or the linear array, we're going to create the radial array. So switch this toggle to radial. And there are a couple of new options available for you here. One is, what is the center of the rotation? What is the total angle of items distribution? And then what is the number of elements? I'm going to choose a number of, let's say, 6 elements. Then I'm going to place the center of rotation, relocate the center of rotation to the center of the table. So you hit this place button, and then to all snap to the center, you can just snap to that triangle at the center of the table. Or if you want to force the center, you can just type on the fly SC, which means snap center. It's another shortcut, SC. Now that's going to snap to the center of the table. And so it tells you what is the method between the first and the last one. You can use this method, or you can define the angle. And the angle of rotation, let's say 6 elements in an angle of 180. So it creates 6 elements in 180 degree. If you later want to change the angle, you may not. You have to undo, I think, unfortunately. So let's try it again. Array, select the element. Array command, place the center of rotation at the center of the table. Indicate the number of items. Indicates the angle, 360. And then enter. Escape. So this also is a new group. When you select any instance, you can change the number of items, 8 or 10. And you can also change the diameter, or the distance between the center of the array and the instance. So it's going to make it grow. 5 feet. 3 feet. I'm going to leave it at 3 feet, but I'm going to do 6. I'm going to return it to 6 elements. And then what you cannot do is change the. Oh yeah, you can change the angle. You know, if you select one of the, if you select the array. I just saw that. So the temporary dimension shows up. Actually, I don't have that. Oh, here it is. If you touch the circle that appears, which is the alignment circle, it will display for you the degrees of rotation. So you can later go back and change it. 170 or 180 or 45. um, Again, the key is to hover over or select one of the items and then select the reference line. And that's going to change. It's going to display the angle of the fill angle. All right, so those are the different methods of rotation. And again, if this is a group that you want to use, say this is a meeting room or a snack bar, you can create a group of this and call this snack table. And this new group will be available under groups, and then you can copy them or just drag and drop it from here. So you need to click not the instance, but the group. There you go. Now, groups is not a replacement of families. And I know this is very, very important. So I'm going to write this down. Groups is not equal to families. So groups is intended to be used when you have like a large amount of elements from different categories. For example, where you're doing an apartment type or a condo type, you're going to have in this group furniture like the bedding, the tables, the chairs. We're also going to have cabinets. You may have walls. You may have electrical equipment or electrical outlets. And when you have elements from different categories that needs to be repeated in the project, that is the proper use of the group. But in this case, for example, these are two elements and they are from the same family. A chair from the same category. A chair is part of the furniture category. The table is part of the furniture category. And if I'm going to use this a lot in a project, the best recommendation is to create a family of nested components, because the family is more efficiently in processing in Revit than it's a group. So don't exceed your use of groups. This group consumes a lot of processing power. To give you an example, you don't need to do this, but I'm going to load a family or insert a family. And this one, it's under tables. I have here is dining around with chairs. We're going to use the second choice. And then under the families, under tables. Okay, this is a family, and this family has embedded all these different chairs. So this is one unit of memory processing versus 7 units of memory processing, because each of these instances is processed individually inside Revit. And so when it comes to memory size, a family is more efficient. It's easy to process, and it reduces the number of, like if I copy this family multiple times, Revit is not going to refresh and regenerate each of these instances because they are consuming the same, unequal, just a single share of memory units. And when I use groups, Revit is considering each of that a separate entity with nested elements, and the nested components are also refreshed. So I am using probably 10 more times memory in groups that I'm using with families. And so try to use families as needed, as opposed as using groups everywhere. So it's not a good practice. Only when needed in certain conditions. Okay, so any question about arrays? Oh, here is a question. How do you explode a group? Okay, see, if I have this group here, I ungroup it. Well, I can edit the group and make changes. For example, I want to change this table from one type to another. When I'm done, I do the finish. Or I could ungroup it. When I ungroup it, I have access to all the instances, but notice that the array from the chairs are still there. So I have to ungroup it. In fact, it's better if I select everything. No, I have to, each of the instances of an array has to be ungrouped. You could, like this is the array model group 4, and they are called all the same. So one thing you can do is select all instances visible in the view, which select everything that has the same model type, and then you can ungroup it. Also, when we create the array, when we in the middle of creating an array, you have this checkbox right here that says group and associate. If I disable this checkbox, a group is not going to be formed, and you lose the ability of modify or access the array properties. So I don't recommend to ungroup unless for sure things are not going to change. Another question, can you make a group into a family? There's not a direct command to do that. I'll have to start a new family, and I choose the furniture template, and then I assemble it the same way I assemble it in the project. I will do it in this family editor. But I'm glad that you brought that over, because when a project is infested with groups, it's going to grow in size a lot. And when it grows in size, your BIM manager, who does BIM maintenance or Revit maintenance to the file, will have to convert a lot of these model groups into families, and that process is very tedious and is very long. And so it will save your BIM manager, or it will save the project time if you convert things from the very beginning. If you use from the very beginning families instead of using a group. When it comes to residential, if you're doing condominiums or apartments, that is an exception. I think you need groups there because you have elements from different categories. Okay. Any other question? We good? All right. So with that, I think I cover everything about the modifiers. I now wanted to address the issue of adding different finishes. And I saw a lot of you do a lot of interior renovation. I know GLP does a lot of interior renovation. And sometimes you need to create finish plans. And so there are different strategies to create finishes. And especially when it comes to floor, the one I like the best, but it has its drawback. There's not a perfect method. Well, I'll go through all of them. Let's say, for example, these are different rooms and the different uses, and they are going to have different floor finishes. Because the floor finishes only appear in one floor plan. I will certainly have to duplicate the current plan and name it accordingly. I'm going to duplicate this view, and then I'm going to rename it as level 3 floor finishes. And now the purpose of this view is just to communicate different floor patterns and different floor types. One strategy to do that is just to draw regions, and a region it's a boundary of connected lines with an applied hatch pattern or an applied fill pattern. It is sitting on top of the view, is the equivalent of drafting things on paper space. It can be connected with some Revit elements, like I can lock and create alignments with the elements underneath. Well, they are view specific. And what that means is that they are not part of the 3D model. They're just representational in nature. They don't modify the model. But they will only display in this active view. So I'm going to represent this floor as vinyl 12 by 12. So I create a fill region. I use a rectangle here. And in the fill region definitions, I have the list of different hatches. I can use the order crosshatch and then click the green checkbox, and that will be a way of represent a finish. Now, what is the drawback? The drawback is that it's because it's a view specific element. It only lives in one view, in this one. The other one is that although it reports areas, and you can quantify it, it's quantified as a detail item. Notice here how this is called a detail item. So it's not part of a floor, or it's not part of a material. It's just a hatch. But for a lot of people, this is sufficient and works. You can send a hatch to the back so that when they are on top of each other, I mean, it's like Illustrator or Photoshop. And in the type properties of these hatches, you can make the hatch be, instead of masking, clear the masking property. And then the elements you see how the door now can read through. It's not a masking region, it's actually a transparent hatch. How we create new hatches, I mean, I already explained the process for you, but in a nutshell, fill regions can be both detail or drafting views. So I'm going to copy this. I select this hatch, make a copy. You can just control drag to make a copy. And if I need to create a new hatch based on an existing, edit the type, duplicate it, and say I'm going to call this vinyl. And in the foreground fill pattern, you see how it says drafting in brackets. It's telling me that that is a drafting pattern. And if I'm trying to do a modular pattern, you have to use the model type. So let's say this is a 12 by 12 tile. And right now it says model. That is always going to be a modular size, regardless of the scale. You can also choose a different background pattern color, especially if you're doing presentation with a client and you want to communicate the color. Let's say this is this type of blue. I'm going to lighten it up a little bit. This is a blue vinyl, 12 inches. It has an RGB color. And the actually, this is, I need to put this number here, not in the foreground pattern is black. No, this is correct. And then the background fill pattern, I need to put solid fill, RGB. So these are two patterns on top of each other. The the unitized pattern, 12-inch orthogonal, and a solid fill, which is RGB. And now this looks like this. And you can use this pattern, place it in a different room, and use these handles to snap it to different surfaces. Now, the difference between two is that this was a drafting pattern and this was a model pattern. And so you see when I change the scales, I'm going to change this to 1/4 of an inch. You see how this changed in size because this was a drafting pattern. And drafting pattern is not suitable for unitized conditions. If I change to 1/32, then it's the opposite scale, and the other remain as is. So make sure you use the appropriate model pattern to represent units, unitized modules. So I'm going to stay with 1/8 of an inch, and we'll delete the other ones. Select and delete. Select this and delete. How do you tag these elements? So oftentimes there is a code, a material code that goes on top of this material, and you can create a schedule of these on your sheet. A very simplified way of doing it is just add the text. This is vinyl 1. There's no really any smart thing about this. Another thing you can do is embed your finished code inside the instance properties or the type properties of this fill region, and then tag it. For example, as an instance property of this pattern, I'm going to add mark VN1. VN-1. And different firms tags interior finishes differently. It's just an example. And then if I want to tag this, just go tag by category and then select the detail item. You may exclude the leader. A leader is going to create a leader. So I'm just going to click the detail item. It's telling me that there's no tag for detail items, so I need to load one. Okay, I'm going to load in the category of annotations. Is under English Imperial. Annotation. Oh, no, detail items here is. No, it's under annotations. Annotations. Detail item tag. This is the detail item tag. And the detail item tag, I'm going to tag it again. Tag by category, select this, and then escape. And notice that these have a question mark. And the reason it has a question mark is because the detail item has a different parameter. So let me do this again for those who fall behind. I'm going to load the detail item tag in order to tag fill regions. You go to the Insert tab, Load Family, go to the English Imperial, annotations, and you're gonna find the detail item tag under the annotation folders. Then under the detail items, under the annotation symbols in the project browser, you're gonna find the detail item tag. And again, this is annotation symbols, detail item tag. You're gonna find two tags, families, one says box, another says standard. I'm gonna select the family and I'm gonna edit the family. And this is gonna open the family browser or family editor. The family editor for this tag, it's made of symbolic lines, which represent this rectangle. And then it has a label. The label reports information contained by the family category. And so when you select the label and hit the edit button in the instance properties, this is going to display the information that it's reporting. It's reporting right now the type mark. And what I want this to report is not the type mark, but the instance mark. And you can actually pick any of these parameters and make it part of the tag. So I'm going to move the parameter away from the label. I use this red arrow pointing to the left and replace it with the mark. And the mark is the instance property of the detail item. And once I do that, I load it into the project. Here you have this warning, and I just want to explain the difference. When you override the existing version, you typically just replace in the geometry, but then you leave the parameter values the way intact, the way they were. If I choose the second one, it's overriding the family geometry, but it's also replacing the parameter values or the parameter, the properties. And I usually pick the second one because I want to make sure that I'm also bringing the new parameter values. And now I'm going to tag it, annotate, tag by category, select the pattern, and notice now how the pattern is reporting the instance parameter. So if I change the instance parameter to something else, it does change it here. This is a smarter way of doing it rather than doing it with text, because there's a connection between the graphic representation of the pattern and the metadata embedded inside it. So for those of you that sometimes do interior finishes, this is one way of doing it. And then and you can create additional hatch patterns as needed. And you can only do like colors sometimes. For example, if you just want to color code it, you can again start copy. I'm going to control drag this pattern, and I'm just going to create it with a simple color. So I'm going to edit type, duplicate it, and I'm going to call this sheet vinyl. And let's say this sheet vinyl, it's color yellow. And so I'm going to remove, there's no fill pattern, so I change this to null pattern. And then for the background pattern, I'm going to select solid fill, yellow color. And the sheet vinyl now it's represented as this yellow thing. I'm going to call it SV1. And this pattern now can be moved into another room and tag accordingly, tag by category as we want. If I need a different shape, you can always edit the boundary. I mean, these shapes just happen to be rectangular, but you can create your own shapes. So the annotate tab, region. This is sketch mode. You can build your finishes any way you want, and then assign it the appropriate color. These are annotation elements, and you can just tag it on top of it. And sometimes, you know, inside a room, you may have two different finishes. Maybe, you know, one is half of the room has one pattern, and then the other half is going to control drag. It's a different one. Maybe it's carpet. You can just split it in half and have carpet in one side and vinyl in another one. All right, and because this is one view, it doesn't have to be embedded in the 3D model. Now let me show you another method, which it's a little more granular in that it's embedded into the elements. I think I showed you this before. But one strategy is to build a very, very tiny floor. Make it like 1/8 of an inch or 1/16 of an inch. And that floor is actually going to sit on top of the structural slab. And so the way to do this is to start a new floor, architecture floor. Let's say this room is going to have a new floor. But rather than doing a generic 12 inches, I create a new type, duplicate it, and you can call it finish dash vinyl 1/8 of an inch. And then you change the structure of this to 1/2 an inch and give it a material. And the material, choose vinyl. Vinyl composition tile. Hit OK. And the other thing you need to do is if I just hit OK here, the floor and the slab are going to overlap, and so the hatch is going to be shown. You see, it disappears. So make sure that you give it a high offset of the floor thickness so that the whole floor is above of the slab. So I give it 1/8 of an inch. And then remember, we switch off these floors in the previous class. So I'm going to go VG and turn the floors back on. And there it is. Now this is a floor. It's 1/8 of an inch in thickness. It's super thin. I offset it 1/8 of an inch, so it's above of the slab. And the advantage of this is that this can be scheduled as a floor, so you can create different schedules as needed. Not sure if that is usually under our scope, but you can schedule it. But it's going to be visible everywhere. This is going to be a permanent floor, visible in every 3D view. So when I switch to 3D view, and then I just want to see the 3rd floor, so orient view to the 3rd floor. Notice how the hatches that I created in the previous one are not visible, but the floor I created for this one is visible. And so this one is going to render. You need to use this type of floor when you do 3D realistic views or you do 3D renders. And if you use this method, I would recommend to name it in a way that are clear, like they are for a user. It's a finished floor, it's not the actual slab. And make sure you put it in a work set. When we do work sharing, I'm going to show you how to do that so that they can be turned off as needed, because the contractor may not want to look at this in some views. So make sure that they are easily switched off as needed. Okay, so those are the two choices, and then you can tag this as a floor. You can go annotate, tag by category, and tag the floor. Again, this is a different type of tag. So I'll have to load a floor tag. And this one, this tag, I think is reporting the family name. So I have to do the same as I did before. Select the floor tag, edit the family, look at the property that it's reporting. Yeah, it's reporting the type name. And I'm going to swap it with the mark value and load it into the project, replace it, and give it a value in the instance properties. So this will be being again, when deciding your finish strategy, think about what is the objective of your work or your scope of work. If your scope of work, it's only do diagrammatic representation of where the finishes are, stick with the strategy number one, which is easy. If your scope includes 3D renders and 3D views, and you actually want to schedule the plans and have a more granular representation of the finishes, then use method number two, which will create floors on top of a slab. All right, any question? Let's move forward then. There's another one I need to disclose, and this is the interior finishes of rooms. So yeah, let's create interior elevations. I'm going to create an interior elevations in this room right here. So oftentimes in our interior elevations, we need to define different materials because they probably serve different purposes. And I need to show you how to do that in walls. I think I already did that when we were talking about walls, but let's refresh it very quickly. You go to the Annotate tab, no, under the View tab, and create the interior elevations, which are here, elevation. Before you click on the view, choose the appropriate family. You want to pick the interior elevation type. And it changed the symbol. And when you place it, it's going to start, it's going to give you with the option of create elevations in orthogonal direction. So you can report the east, north, south, and west. This particular tag, it's reporting the elevation name. I'm not sure I like it that. I mean, I would rather use a different format, but I had just created 4 different interior elevations. If you go to the view branch of the project browser, you're going to find these 3 the elevation, interior elevations, or 1A, 1B. Maybe what we need to do is rename it and remove the word elevation. And so notice how now start renaming what is reported in the elevation tag. And so to look at the elevations, just double click one of them. The elevation was placed on level 3, but it's expanding from level 2 to level 4. That is a mistake. So one thing I'm going to change is switch to fine, and then also switch the elevation scale to half an inch or 3/4. Let's do 3/8, and just stretch them up. This is the elevation from level 3 to level 4. And and then one thing you can do is select element by face. So this is a wall that I have selected by face here. If this wall, this particular wall, actually this is a group, I have to ungroup it in order to access the wall. So let's go back to level 3. Let's ungroup this group. So select this group and ungroup it. You select just the group and ungroup it. So in the interior elevation, now I have access to the wall. And if this wall is going to have 2 finishes, let's say half of it is going to have one color and half of it is going to have another color, then you can apply different materials to different wall surfaces. So let's go to the materials first. So let's make sure that we have the appropriate materials. So you go to the Manage tab, Materials, and let's see if we have paint here. There's one called Parking Stripe. So I can duplicate this. I'm going to call this Paint 1. Paint, let's call it blue. And I'm going to do another one, duplicate. Select paint blue and duplicate it. I'm going to call this paint red. 2 types of materials. All you need to do is change the color in 2 places. You have to change it here in the appearance to blue, and I'm going to put a little light here. And then on the graphics, I'm going to use the render appearance so that it also appears as blue. Oh, you see what I did? I did a big mistake. I didn't duplicate the asset. So I'm going to cancel this because I am modifying all this in a bulk. So my bad. I'm going to go to the Bastilla browser again. I'm going to search for the paint. I have a parking stripe here, so I'm going to duplicate this, and I'm going to call this paint blue. And then when I go to the appearance library, notice how there's an asset called canary, and I didn't duplicate it. If I don't duplicate the assets, I'm going to change the assets in all the materials that are using that one. So I need to duplicate these assets, and I'm going to call this new asset. I'm going to call this blue, and then I'm going to change the color. I'm going to change this to blue color, make it a little light. And then on the graphics, use the render appearance, and notice how the paint blue, it's now a unique material. Apply it. So now I'm going to duplicate this paint blue, and I'm going to create another one called paint red. Paint red. And again, I need to go to the appearance library, duplicate the asset. Duplicate the assets is very important. And call this a red paint and then change the RGB color to something that's red. You can change other things like, you know, the finish, whether it's matte, eggshell, pearl, semi-gloss, or gloss. And these have direct reflection on how it renders. And you can even change the application. Tint is just give an extra color to the paint. So I'm not going to do that. It's like if you were like varnish it with something else. So this is, I have two new colors, paint blue and paint red. And I'm going to do another things. I'm going to show you how to add material keynotes. Material keynotes is identity metadata that lives with the material and can be used in Revit to report material tags. So the paint blue, for example, can be a chip that in my specs is called PT2. And I just add that into the mark value of the paint blue. And my paint red could be also a chip with the key PT4. So I have two materials with two different mark values. And these mark values are going to be part of my interior elevation tags. And here you can continue building your own materials. For example, if you're using wood or you're using whatever finish you're doing, you know the process of creating materials. But the key part is that you add this mark value inside the material properties. And so now that I have those two elements in my wall, two materials, I can apply it to different regions of a wall. So let's say I'm going to split this wall in half. The bottom part, or the chair rail, under the chair rail is going to be blue, and above that is going to be red. So in order to do that, I have to use this command in Revit called the split face. And a split face, it picks the exterior surface of an object and create a new boundary around it. In this case, I'm going to split this wall in two parts. So I go split face, and then I select the wall I want to change. And these expose the sketch lines of the wall. The sketch boundaries, the original sketch boundaries have this yellow-orange color. And then I can define new boundaries to contain different materials. But in my case, I just want to split it in half. So all I need to do is create a sketch line at 4 feet from one jamb to another jamb, and then hit escape. That's it. Use the temporary dimension to reallocate the size of the location of the split to an extent. And then when you're done, just hit the green checkbox. And I have a wall with two regions. I'm going to switch this to shaded color. And right now it still has the original wall color. But what I need to do now is use the paint tool. And the paint tool will apply a material to the face region of an object. So paint is like grabbing your brush and place it on the regions. So when you do that, these are the two chips of paint that I tried. So pick the material you want to use and then click it on the surface you want to apply it. Again, click the paint you want to use and click it on the surface you want to apply it. And these are two colors. And these are going to render as appropriately. And then the last step is to tag it. So to tag an element with the tag number inside the material, I go to the Annotate tab, and then you use the material tag, this material tag. And the material tag, you select, I'm going to use a leader. Right now it's a question mark, but we're going to take care of that. And that's because the material tag is reporting a different parameter. It's not, what I need to do now is to edit the family, select the material label, and swap the label from description to mark. Remember that mark was the value in the material library that I infill information. So all I'm doing is swapping the information that the tag is reporting and loading it into the project where it's going to be replaced. And now notice how this is reporting the material, the parameter embedded in the material. I don't think I did that for the blue color. Did I? Oh, I did. Let's go back to the material and look at the blue paint. Identity. Oh, no, I didn't put one. This will be a PT 5. There you go. And so if you change the material, the tag will update automatically. Some firms decide that it's not worth embedding that much intelligence, and they just use regular text with a segments of with the segments, but maybe for a small project that's okay. But if you have very large projects and the decisions are going to be percolating, I mean, the decisions are going to be there's going to be a lot of interactions in the process, in the finishes, then you can do a little more of effort and embed the information inside the materials. And therefore, if you pick the material and you need to update the label, just go to the mark value and change it. And then it's going to, this label is going to update across all the elevations in the entire project, as opposed to just regular text that has no intelligence into it. That makes sense. All right, so I know this is going to finish. You can do this. The same process can be done for floors that have different finishes, or for ceilings, for example. When you have 2-3 different type of ceilings, it's exactly the same process. You focus on the materials, add the metadata, add the color and the projection surface patterns, and then add material labels. But yeah, take advantage of the smart tags because they are time savers for you. All right, and you don't have to do this, but if, for example, I needed to define an area for a painted whiteboard paint, I can go back and add additional subregions. And let's say, okay, this is an area I'm going to paint for a whiteboard. And then you go to the material library and again, duplicate your material. And I'm going to paint for white. And go to the appearance library, duplicate the assets, whiteboard, and give it, I don't know, a light gray color. And then hit OK. Oh, and in the material library, I'm going to call the identity data whiteboard pane. And I just tag it now. So under modified tab, paint, search for the whiteboard and click in the center, and then tag, annotate, tag by category, annotate, sorry, annotate, material tag. There you go. The question from B, can you achieve the same thing by building the finishes and materials into the wall type? You can do that, but then you have, for every change of color, you will have to create a new type. So for example, you'll have to have a type for the red color, a type for the blue color, a type for every color. And I think if you start managing finishes and the type definitions, you're going to end up with a lot of different types. Please add in an extra management level, but it's possible. The split is something you could do also in wall types. But also remember that it might be a little misleading because the wall structure in Revit must have a thickness. And so your paint must have also a thickness level. Or maybe you can do the entire Gboard wall board, a material with a color. Like this could be Gboard painted blue, Gboard painted black. Then you start creating multiple materials, multiple wall types. I shy away from using that method. All right. Any other question? All right. So hopefully this is helpful for my interior designers online. Let's move to vertical transportation. So I'm going to have to do this exercise in the structural element, not because that's their scope, but that's where I have all my floors. And that is probably the place where I could model the stairs more quickly. So I'm going to save this file. If you don't have the file, I put a link earlier in the class for the data set. That's where the structural element is. I'm going to close this file. And I'm going to open, I'm also going to close all these tags. And let's open the structure. I think it's my first building a structure. And this is where I have all my slabs. And what I'm going to do now is to display how to create a multi-story shaft opening and how to create multi-story stairs and multi-story railings. And let's, for this discussion, maybe go into the, let's go to the drive. And in the summer, in our data sets, there is a folder called stairs and railings. I'm going to post a link to these in the chat panel. Get link, copy link, and these are stairs and railings. Just hit that link that I posted, and feel free to download these files, the railings and the stairs. Just right click, and download. You just double click and download it. Stairs and railings are system families, and they cannot be brought into the project as component. But what a lot of firms end up doing for system families is that they create something called a container file. And a container file, it's a project file that contains multiple definitions of different system families. In fact, you know, I believe GLP, I helped a long, long time ago to create your typical interior partitions container file, which is a file that has, you know, 100 specific wall types. And what you do to use them is open the file, copy the types that you need, and then paste it into the project. So system families cannot be brought into the project as components, but they can be copy pasted. And so let's open this container file. So I'm gonna open the file I just downloaded. So it should be under the download folder of this PC. And let's start with the railings. Oh, it's 2019. May take a few seconds to upgrade. So the railings, it's system family, but it's very like the curtain wall is made of different components. This is a container file, and you're free to use them for work if you want. But these are multiple definitions of railings arrayed in a tabular display. And in fact, in your practice, you should have something like this, so you don't have to start from scratch anything. One of the most frequently used handrails are, you know, the guardrails with pipe and extensions. This is typical of exit stairs. This is another one that is frequently used. This is the wall handrail. Used a lot in interior conditions. And this is the stair handrail with pipe with extensions, maybe for mechanical equipment access or mezzanines. And so all these types are available to you. You use railings also for doing fences. For example, this is a picket fence. You can use fences for representing this is a lot of residential fencing. And surprisingly, you can use also a fence, a railing, to create this type of overhangs. For example, if you added a path of array of these, that's how it looks like. It's just one sketch line, and that sketch line will create for you an overhead risolet. All right, the way you create a railing is very simple. You go to the architecture tab, hit the railing tab, and you hit sketch path. This is going to open the sketching draw tools. And this is one of the few elements where you don't have to have a closed loop. Pick the railing type you need, and these are all the different types. I'm going to do the handrail pipe with extensions. And then you hit the first click, second click, third click. This is in meters, and this is the railing. The railing also displays this symbol, which indicates the exterior side. Some railings have an interior and exterior side. And when you click that, it flips the direction of the railing. This one, it just happens to be the same. You can change types by using the type selector. Here, I'm going to swap it with this deco type or with this parapeto. Yeah, it's like wood, heavy wood. But I want to return it back to the railing, rail pipe with extensions. And let's look a little bit of the properties behind railings. This is one of the most complex families, so I'm not going to spend a lot of time explaining how to create one from scratch. You can use any of these as your placeholder to get started, and then you can customize as needed. But let's see. I'm going to put this here on a side and look at the type properties of a guardrail. One thing I'm going to do is quickly change the units because this was in meters. I can see from the scales here. So I go to the Manage tab and go to Project Units and switch the area to square feet, distance to feet, length to feet and inches. That's all I need. Yeah, so area and maybe volume, cubic feet. So I changed the area, the distance, the length, and the volume. All right, so this is my guardrail with pipe extension. Let's look at some of the type properties. The construction of a railing is made of something called balusters, the start post, balusters, posts, and railings. And so again, there are three components to the stairs, to the railings. The railing profiles, the posts, and there are two types of posts, the start and the end. And the balusters. The railing profile are the horizontal profiles extruded along the length of a railing. The post start and the post end is the family right at the start of the railing and the one at the very end. And the baluster is the infill family that sits in between the start and the end. So in this case, the railing profiles these are the horizontal ones. This is the start, and then the other one is the end. And then the balusters, the intermediate balusters are all these intermediate families that are arrayed in between the start and the end of the assemble. And so just to understand how this is put together, I'm going to select this railing, edit the type, and look at the rail structure. And these are profiles. A profile is a two-dimensional line that is closed. And these are the different heights of the profile extrusions. You can assign materials, type materials, or you can just leave it as is and you can assign it later. It has a top rail at 3'6", and it has a handrail, which you can see right here, which is 2 3/4 inches away from the center. So that is that railing. So this dialog box defines all the horizontal extrusions of the railing. Easy, right? You can change the height parameters as needed, or you can add additional guardrail by clicking the insert button here. Again, if you're going to make changes, remember to duplicate, rename, and change parameter values because you don't want to change the original definition. Here's a preview of how that looked like. we hit the preview here. You can also change the preview to front elevation. And that's exactly what you see here. The top rail, second, the third, all the way to the eighth. All right, that was easy. When it gets a little bit complicated, it's in this baluster placement. And baluster placement is it's a distribution of the posts and the distribution of the balusters. And so the easy to understand is the post. The start post has a specific family. You can say if you highlight this, it tells you what that family look like. This is the end post, and you can see it here what that means. So in this case, these specific family has an extension, but they are in different directions. And then this is the relative location from the railing base and different offsets in the horizontal and the vertical. In addition, you have here a corner post. And a corner post, it's a family when there is a change in direction of the family. For in this case, this will be a corner post because there's a change in direction in the baluster construction. And then we have the main pattern. It's the infill balusters in between the segments. It's a round 1-inch family. The base of this family, it's inherit the base of the host. The host is the whole assemble. So typically it's always going to be host, but you can change it to other horizontal elements. Host mean inherit the elevation of the parent assemble. May offset, raise it up or down as needed. Say, for example, I change this to -1. Then from the host is going to be at -1. And then it extends from this bottom to the top rail. You can also make it to a different rail as needed. Top offset. In addition to that, you want to have additional distance. Distance from preview is what is the distance between them? And right now it's 2 feet. Now, if you start offsetting those balusters at a specified distance, you're going to have a residual panel. And that residual panel is controlled by this justification. When you justify it from the beginning, it's going to start measuring increments of 2 from the start post, and then it's going to leave a residual distance at the very end. If you justify by end, it means that it's going to use the end post as the start point to do the distribution of 2 feet. But if you change it to center, it's going to use the center point. It's going to place a baluster at the center, and then it's going to start spreading it. And then you're going to have equal residual at both ends. I like also to use this spread pattern to fit. It's not going to be exactly 2 feet, but it's going to be at a minimum of 2 feet, a maximum of 2 feet. So it's going to spread evenly all the posts along the path. All right, so this is what this means. Break pattern means do you want to start the pattern sequence after every segment end, or angles greater than means um, when you have a when these angle between these two planes exceed a certain minimum, then you're gonna add this break pattern. Or if you say never, then it's never gonna place this post here. Actually, that's what this is, sorry. Corner post at each segment end, angles greater than or never. And the same is true for the balusters. I think by default, you could say at each segment end, you want a baluster. All right, again, in this class, we're not going to create one of these from scratch. But let me show you a little bit, something that's a little bit more complex. Let's look at this, for example. This is it's a glass panel with brackets. When I edit the type, there are 3 horizontal railings there's a 2x2 at the top. There's a handrail 1x1. There's another rail at 4 inches from the floor. That's the easy part. But when I look at the baluster placement, then this is the start post. This is the end post. And then a corner post happens at every change of direction. Then these have the main pattern, the main baluster pattern, have two patterns. One is the square, so it will be this one. That is that one. That starts from the very bottom of the hose all the way to rail number 1. That's what they mean. That's this element here. And then it has another pattern, which is this baluster panel glass with brackets. So this element here that I'm clouding, that is this family. And it's going to be placed at rail number 3, which is this guy. Rail number 3. It has a base offset of -1. I mean, I have to open the family and see how it was constructed, but it's like lowering a little bit, and then extended it all to rail number 2. It also has an offset of -0.5 inch, and then these balusters are placed 1.5 feet in between. So the distance between these and that, it's 1.5 feet. And then this pattern gets repeated over and over. It's justified center. So what that means is it's going to have, these are residual panels. And it says whenever there's a residual panels, don't do anything, don't put anything. And that's how it works. I mean, these families can be customized. You can create a new baluster from scratch. I don't have time to do that now, but that's how the family works. If I need to use this in my project, you just copy this to the clipboard, switch to the project, and paste. Modify, paste from clipboard. If there are materials with a redundant name, you're going to get these warnings. Place it. And now these I'm going to delete because the only thing I needed is to bring this family to bring the definitions. But in my project, I cannot create that railing. So in the type selector, I have the handrail glass with panels. And all I need to do is bring it from the other file and start using it in the project. All right, so that's how, that's the purpose of these container files. It allows you to have multiple system families and bring them into the project. I'm going to just quickly open the stairs and maybe leave the stairs discussion for next class. But I just want to show you also that the same logic behind railings you can do for stairs. You can have a container file with different stairs. And when it comes to use them into a project, just select the type that's appropriate for your design intent, copy to the clipboard, and paste it. And when you paste it, it's going to bring the definition inside the project, and you can start using it without crafting it everything from scratch. So let's save this file. I'm going to pick it up the discussion actually next Tuesday and finish the stair discussion. And then right after that, if you look at the what's next, I'm going to start talking about shared coordinates. So with that, we finish the modeling tools, and then we're going to move to shared coordinates. And so this is going to, I'm going to show you how to enable multiple models to align using a common share point. And what's the appropriate process and what are the best practices around that, and how you work with CAD files with civil drawings in CAD, how you make them align with your project. That should cover a lot of the next class. Probably I'm also going to have time to talk about parameters. Yeah. Any question? Let's see. Question. All right. So it's 7:20. I'm going to stop the class now. And again, if you want to stay over and have a one-on-one with me, feel free to stick around. Otherwise, I'll see you guys in a week. All right. Okay. I'm going to stop the sharing. Stop the record.
Thank you, Cesar. Bye.
All right. Bye, Steve.